As storms and droughts increase and sea levels rise with climate change, forested wetlands up and down the Atlantic coast are transforming from vibrant ecosystems to landscapes filled with dead or dying trees. The accelerated spread of these ghost forests has ecologists alarmed and eager to understand what effect they'll have both regionally and globally.
A ghost forest is a very clever name for a kind of unfortunate new habitat type we're seeing growing on the coast. And it's a place where you have a lot of dead trees, large areas of contiguous forest that are just gone.
My emotional response is to mourn the loss of those trees. But scientifically, I say, what was the combination of stresses that caused this particular stand of trees to bite the dust?
We've been doing this now for close to a decade, and in that time, we've already been seeing changes. If these things are changing on a timescale where I can see it, what's going to happen for this landscape, by the time my kids grow up? My name is Marcelo Ardon, and I study ecosystem ecology and biogeochemistry of streams and wetlands.
And I'm Emily Bernhardt, and I am a biogeochemist and aquatic ecologist.
And I'm Ryan Emanuel, and I'm a hydrologist.
Believe it or not, back in 2004, this was a really large 440-acre farm that was purchased by a group of developers who decided to turn it into a wetland. Because we were studying this wetland restoration project, it didn't even occur to us that saltwater would get here. And we recognized a year after the first intrusion event happened that we had gotten to near brackish conditions in much of this wetland.
And that's what kind of led us into this research of saltwater intrusion and trying to understand if the patterns we had seen in this restored wetland were also happening in the broader area of the Albemarle-Pamlico Peninsula.
The Albemarle-Pamlico Peninsula is a landscape that's dominated by water.
So we have the Pamlico Sound in the south and the Albemarle Sound in the north. We have the big Alligator River sort of cutting down through the middle of this peninsula.
Ecologically speaking, this used to be all dominated by wetlands. Tends to have very organic, rich, peaty soils, and it's a system that would sequester a lot of carbon in the soils.
The Albemarle-Pamlico Peninsula has a history of large-scale commercial agriculture, vast tracts of land that are used for corn, soybean, crops like that. No matter where you go on the peninsula, you can see some type of artificial drainage infrastructure.
You can even use Google Earth and Google Maps, and you can see some of these changes, on your computer.
Even though they were made to drain water from the interior out to the estuary, there's the potential for them to serve the opposite purpose. You can have storms that push salt water deep into the interior, often through ditches and drains that may not have flow control structures or other protective measures.
Now when you have a drought, the sounds get saltier, in part because they're evaporating and in part because they're not getting fresh water off the landscape. So you start to see those salts mixing up.
You could actually have gradients of salt water that penetrate deep into the interior through these ditches and drains. One of the impacts of climate change is a likely increase in the number and severity of droughts and the intensity of storms. In both of those cases, we're actually influencing different types of saltwater intrusions.
The thing that's actually happening is that salt is getting into a landscape and killing individual organisms, be they trees or microbes. So it's actually happening at a very granular scale. But what we want to know, and I think what most people want to know, is how the coast of North Carolina is going to change as a result of saltwater intrusion. Our team is a hydrologist, 2 biogeochemists, a plant ecologist, and a social scientist, all trying to think about how can we bring our expertise to bear in this really multi-layered, difficult question.
We're collecting data from more than a dozen sites around the peninsula.
So we measure the water chemistry, we measure the water level, nutrients are there, how much salt is in there. We also monitor the soils, the chemistry of the soil. We look at the greenhouse gas emissions. And then we've also started measuring greenhouse gases from trees Is the tree functioning like a chimney? So is it taking gases that are being produced by microbes in the soil and releasing them out into the atmosphere? Or is it more like a cork, and is it actually helping to keep gases that the microbes are producing in the soil within the soil?
All of these things are monitored continuously at a handful of sites around the peninsula, but we also have handheld tools that we can use to make spot checks as we drive around broadly.
What we would really like to do is link what we're seeing with vegetation, areas where we know there's saltwater intrusion occurring, to what we're seeing in the soil. So yes, there's salinization here. This is what the trees do when that happens.
Using geospatial data, we can try to see if what we see in these small places are going to apply to much larger areas.
We're currently using digital elevation models to assess how vulnerable the landscape is to saltwater intrusion. We're using these algorithms that tell us how water concentrates and flows across the surface and how connected or disconnected different parts of the landscape are to one another, combining those metrics in ways that allow us to come up with an estimate of vulnerability. And when I look at those maps, I get a sense of the magnitude of this problem. Some of those salts can stay behind in the soils, so you may see reduced yields in crops, and there are forests nearby. That could be one of the factors that leads them to become ghost forests. We think that ghost forests are spreading throughout the Albemarle-Pamlico Peninsula and throughout many parts of the eastern U.S. The pace of sea level rise and the intensity of human modification of the landscape have accelerated that process. I've never worked on a project where the change is happening at such a rapid timescale.
It is possible that we might not fully understand this problem before it's too late. So this area is actually one of the highest sea level rise rates in the country.
You could be very fatalistic and say, just let it go underwater. And I think that would be unfortunate if that's the decision that we make. There's the enormous standing stock of carbon in the trees and the soils of all these coastal wetlands that could be lost back to the atmosphere. And then there's the biodiversity loss. If we lose these so fast, we're just going to lose this really important ecoregion. Where we can be hopeful is that there are a lot of things that we could do to manage this landscape differently than just abandoning it to the sea.
One of the things we hope to do with our research is to provide decision makers with tools that they can use to potentially mitigate some of the effects of saltwater intrusion that are caused by ditches and drains.
Rather than it being an on or off switch where it has to be either we build a ditch or we plug it, can we find ways where we allow water to move in one direction but not maybe allow it to move in another direction, or even maybe trying to figure out if there are maybe crops that would be more salt tolerant that are growing out here. And the same thing for these wetlands. So restoring it to what used to be here historically is probably not going to be the smartest idea. And starting to think about what species are going to do well, can we use those species for restoration?
If we do nothing and we continue to farm, we continue to build infrastructure as if these forests and these systems are not going to change, then we might be in for some really rotten surprises in a few decades.
I think humans can have a huge impact on both whether new ghost forests develop, whether current ghost forests expand, and also what happens now once a ghost forest exists on the landscape. Do we leave them? Could we manage them in a way that we might actually move more rapidly into a sort of a salt marsh ecosystem? I think there's a lot of interesting decisions that we could begin to make. They're not going to be forests in those places probably again, but they might be something equally interesting and beautiful.